Today. I'm going to run you through how to examine relationships using measures of association and tests of statistical significance for crosstab data. We're going to look at ordinal relationships and nominal ordinal relationships. So today we're going to have to pay a little bit more attention to um, certain measures and what it is that they tell us. So in terms of adding on commands this week, we're really only adding two different commands to the sort of stuff that we've already examined. So again, this week we're going to be focusing a little bit more on interpretation than we will be on adding new commands. So the first thing we're going to do following along with the book is to take a look at the relationship between individuals who want to use force and education. As you can see, we're adding really no new commands. That's in the SW. Until right here. What we're asking it to give us is the chi-squared. The chi-squared test we'll talk about here in just a second. So let's go ahead and take a look at this. The reason why we're looking at expected count is because expected, that's what the expected is right here. The reason why we're looking at expected count, and we'll just take this first row as an example, is expected count is precisely how the chi-squared test is calculated. So chi-squared tests whether the relationship you're examining deviates from the expected relationship that would exist if there was no relationship. So the expected counts if there was no relationship between the two variables. So as you can see, this row right here is the expected count. So the expected count here is 63, and the actual count that we have is 91. That's a deviation. And so what the chi-squared test does is it gives us an overall test of the deviation from a null relationship. The final chi-squared scored for this relationship is 71.6. Now that in and of itself doesn't tell us a whole lot. So what we need to do is we need to see if that test is statistically significant given the degrees of freedom within the table. Now, the way in which you calculate the degrees of freedom within a table is taking the number of columns minus 1 and the number of rows minus 1 and multiplying them together. So in this case, we have 4 columns, so that's 3. And we've got 5 columns, so that's 4, so that's 12 degrees of freedom. 3 times 4 is 12. And the way we calculate this is by typing, and now here's where we plug in what we said. So this is the degrees of freedom, the 12 that we already calculated, and the overall chi-square test, which we have up there, is 71.6. And it tells us that obviously this is an exceedingly, this is a relationship that is statistically significant at, I think, the 0.000001 level. So that's when we say that something is statistically significant if the probability is below 0.05. This is exceedingly below 0.05. So it's absolutely a statistically significant relationship. Now we need to examine the strength of that relationship. The way we do that is using measures of association. So on your own installation, on your own Stata at home, what you need to type now is ssc install SummersD. I've already done it, so even when I hit enter, it's going to spit back that I've already got it installed once it figures that out. All files already exist and they're up to date, so I've already installed it. The correct format for that, for the next command, is SummersD, and then the exact same command we did before, except this time we're going to use probability weight. And that's it. And it spits us out some sort of calculation, and it gives us this coefficient. Now, this coefficient is the measure of association. It tells us that we're better off predicting opinions on international force when knowing education by about 6%. Now, you can interpret this as a percent because Summers D is what is known as a percent reduction of error measure. And it tells us how much error we would fix by just naively attempting to predict international force. So by knowing education, we predict international force 6% better. That is what this measure says. Now, the way in which you should do these commands, order in which you should do the commands, is first, get your chi-squared test. You don't need to use the expected. I was just using that as an example. So we'll take that out. First, do your chi-squared test. You're going to get this number. Then you're going to want to calculate the p-value of that chi-squared test, which you'll get right here. And the next thing you have to do, the next step, is to do the Summers D. And you'll get this coefficient, which will inform you how much percent reduction of error there is. The book goes over how to interpret and report these results, and it does a great job of it, so I just advise you to look there. So the next question is if we want to include a control variable, how do we do that? And the answer is we do it the exact same way that we did last week. So we're not going to put the colon there. We're going to sort it by libcon3, and we're going to do exactly the same command. We're going to tab international force and education 4 if liberal conservative does not equal missing. So we suppress that. We don't need to use the expected. Like I said, I was just doing that to give you an example. So what this should do is it should spit out 3 relationships to examine whether, when controlling for liberal versus conservative, does this relationship still maintain, and does it augment the effect of that relationship in any way? So as you can see here, the chi-squared test for liberal is 27.6, for moderate is 22.3, and for conservative is 48.2. So we'll just quickly go through and calculate all of those probability tests for the chi-squared. It's very easy, chi, two-tail, and we still know that it's still 12 because that's still the degrees of freedom in the table. And the first measure for liberals is 27.6. And that's below 0.05. So we know that that's a statistically significant relationship. Again, if you want to bring up the previous command in Stata, you hit the page up button and it'll bring it into the command window. And that way we only have to edit, in this case, the chi-squared statistic, which for moderates is 22.6. And that at 0.03 is below 0.05. So again, that is a statistically significant relationship. And then we enter the one for conservatives, which is 48.2. And that is much below 0.05. So again, that's a statistically significant relationship. Now, if we want to get the measures of association, the Summers D measures, we only modify the command a tiny bit. So I'm just going to go up here and modify the command. And I'm going to put Summers D, international force, education, if libcon equals 3. Again, change that to probability weight. And then we can delete all this stuff afterwards. And what this will do is the same way the bisort tabulate command did with the chi-squared, is this will give us 3 boxes in which each of our measures of association will populate. So as you can see, measures of association for liberals, measures of association for moderates, and measures of associations for conservatives. So you can see that when controlling for the liberal conservative dimension, this relationship still exists and is still in the same direction, but the magnitude of the relationship changes a bit. So remember, overall, it was around 6%. Within liberals, it's around 7%, almost 7.5%. Within moderates, it's almost 8%. And with conservatives, it's 2.4%. So the direction of the relationship is same across the ideological spectrum. So that's an important finding to come to, and this is exactly how you would assess and report it going forward. Now we're going to take a look at nominal relationships. This is the last one that we're doing for today. And to that, we're going to open the GSS. The GSS has you create DivLaw 3. I've already done that. So this is the way in which we're going to start off. Now, why are we looking at something different here? It's because we're analyzing a nominal ordinal relationship. Nominal ordinal different from ordinal, and so we have to use a different measure of association to actually assess what the relationship looks like. So we're going to use DivLaw 3 and marital. And so the command really isn't all that different for the first part of the setup. And that is, the same. So we have our overall chi-squared statistic. Now, again, we're going to calculate our degrees of freedom. And here we have 1, 2, 3, 4, 5. So 4 times 1, 2, 3 times 2. So the degrees of freedom are 8. So it's di chi two-tail 8. And as is highlighted on the screen, 85.4. You see, statistically significant relationship. We're all good. Now, what you're going to do what measure of association that you're going to use for nominal ordinal relationships is not the Summers D, it's Cramer's V. This is not a percent reduction in error measure. So it cannot be interpreted in the same way that Summers D was. Nor is it as easy to actually calculate as the Summers D was. There isn't any sort of package that we can install to easily do it. So the book gives you the command in order to do so. And I have copied the command and put it in a do file. They recommend you do the same, and I absolutely recommend that you do the same, because here is the command. You're literally pulling things out of the rows and the columns. That's what R and C is, the total number of cases, the square root, and then this is your chi-square score right here where X is. So I typed it a little different than the example in the book. I put X here sort of to distinguish that every time that I have to enter this, that's the variable I have to edit. And in terms of editing it, I will put 85.4 and then hit enter. And it gives me the Cramer's V as 1.544. Now, what does that mean? We know it's a statistically significant relationship. We've run that here. This tells us this 1.54, this measure is bounded by 0 and 1. So 0 is a weak relationship. 1 is a very strong relationship. So where would 1.5 sit? 1.5, or 0.15, it is a fairly weak relationship. It's statistically significant, but it's not very strong. And that's really the best language that you would use to describe it. As you get closer to 1, you see stronger relationships. Within the 0.5 area and around there, those are moderate relationships. And really anything below 0.3 we would call a weak relationship, though it is still statistically significant, meaning that the relationship absolutely should exist within the population. It's just not a very strong relationship. Those are the only new commands for this week. So you should be able to replicate the homework pretty easily. Just remember that Summers D is a percent reduction error measure, a PRE, whereas Cramer's V is not a percent reduction in error, so we need to differentiate in how we communicate those. So this week we'll be looking at the chi-squared tests and these measures of association, depending on whether you're using an ordinal-ordinal relationship or an ordinal-nominal relationship.